Hello, and welcome to this lesson on operators. This lesson is a part of the course Python for Beginners. My name is Buddhika Karunaratne, and I am from the University of Moratuwa. In this lesson, we will discuss the different operators available in the Python programming language. This is the standard color coding for the presentation slides, and it is consistent with all the presentations in this series. Let's first look at what an operator is. Operators are used for performing operations on variables and values. And what are operations? The simplest operations we know are addition and subtraction. The values that an operator acts on are called operands. In this example, plus is the operator, x, a variable, is the first operand, while 5, a value, is the second operand. Arithmetic operators are used for performing common mathematical operations in Python. The table you see shows Python's arithmetic operators with their symbols and meaning. We have the basic arithmetic operations: addition, subtraction, and multiplication. Then we have two types of division, standard division and floor division. Standard division always results in a float or a floating point number, whereas in the floor division, the fractional portion of the result is truncated, is removed, in other words, and only the integer part is kept. You can see in the examples how the division of 12 by 5 results in 2.4 and 2 with the two different kinds of operators. And also, we can have the exponentiation and modulus operations as well. Assignment operators are used for assigning values to the variables or any other object in Python. For instance, x equals 5 is a simple assignment operator that assigns the value 5 on the right to the variable x on the left. There are also multiple compound operators as depicted in the given table. For example, x plus equal sign 2 adds 2 to the variable x and assigns the result to x. This is equivalent to x equals x plus 2. And hence, the value of x will be 7. You can go through this given table to learn about all the compound operators in Python. It's kind of straightforward to understand. However, if you feel uncomfortable with using compound operators, you can always go for the more regular and generic operator type. So in that case, you can just use the regular operators as shown in the alternatives. Let's move forward to the next type of operator. So here, comparison operators. They are used for comparing two values. Since it returns either true or false, comparison operators are typically used in Boolean contexts. They are especially used in conditional and loop statements in order to direct program flow. And you will see this in a later session in detail about this. We have greater than, less than, equal to, not equal to, greater than or equal to, and less than or equal to as comparison operators. As we can see here in the example, the result is a Boolean value. 5 greater than 2 returns true, while 4 is not equal to 4 returns false. It always returns a Boolean value, either true or false. Logical operators and or and not operators are used to compare two conditional statements. The logical operators modify and join together expressions evaluated in a Boolean context to create more complex conditions. When using the AND operator, the expression will only return true if both operands are true. Whereas using OR operator will result in true if at least one of the operands is true. Finally, the NOT operator will only give true if the Boolean expression in the operand is false. Identity operators is and is not are used to compare two objects. Not if they are equal, but if they are actually the same object located on the same part of the memory. Hence, two equal objects do not necessarily imply that they are identical with the same identity. Here is an example of two objects that are equal but not identical. X and Y both refer to lists containing the same elements. They are equal but not identical, as they do not reference the same object in memory. So when you try X is Y, it will return false. You can verify that X and Y do not refer to the same object by using the ID function as shown on the right side. When you make an assignment like X equals Z, Python merely creates a second reference to the same object. Therefore, when you try X is Z, it returns true, because basically it is the same thing. As you can see, both X and Z have the same object identity. Membership operators in and not in are used to test whether a value or a variable is found in a sequence. A sequence can be anything from a string, a list, a tuple, a set, or a dictionary. Similar to identity operators, membership operators also return Boolean values, either true or false. For example, here we have a list with A and B. The statement A in list returns true, because actually the item A is included in that list. The statement C not in list also returns true, as C is not an element in that specific list. Now let's look at bitwise operators. These are similar to logical operators, but treat operands as binary values and operate on them bit by bit. For example, 5 is 101 in the binary format, and 7 is 111. When you perform the AND operation on these operands, it will give you the output 5101 in binary form. Since you performed a logical operation on each bit of the numbers, one at a time, this is precisely the same when you perform OR and XOR, that is exclusively OR operations, but using the appropriate logical operation bit by bit. Exclusive OR or XOR will return true only if one bit is true, not the both of them. You also have the right shift and left shift operators. Left shift shifts left a binary value by pushing zeros in from the right and letting the leftmost bit fall off. Right shift, on the other hand, shifts right by pushing copies of the leftmost bit in from the left and letting the rightmost bits fall off. In Python, an integer is usually represented in 32 bits. When you ask it to shift an x left by 2 bits, it takes the 32-bit binary representation of x and shift it right by 2 bits, as shown in the example. The resulting binary value is 20 or 20. Similarly, you end up with 1 after right shifting x by 2 bits.